हेलो 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 डियर स्टूडेंट्स, अब हम पढ़ेंगे सर्कल्स के बारे में। सर्कल के ऊपर बेस काफ़ी सारे रिजल्ट्स हैं जो हमारे काफ़ी सारे काम के आएंगे, तो हम उसके ऊपर चीज़ें करना शुरू करते हैं। तो सर्कल को वैसे हम डिफाइन करते हैं, सर्कल इज द लोकस ऑफ ऑल दोज पॉइंट्स इन अ प्लेन which moves in such a way whose distance from the fixed point in the same plane is always same। यानी सर्कल जो है वो पाथ है उन सभी पॉइंट्स का जो एक प्लेन के ऊपर है, जो इस तरीके से मूव करते हैं जिनका डिस्टेंस एक फिक्स पॉइंट विच इज कॉल्ड द सेंटर ऑफ द सर्कल हमेशा सेम रहेगा। कुछ मेन रिजल्ट्स इसके हैं कि अगर आप सर्कल के सेंटर से किसी भी कॉर्ड के ऊपर अगर परपेंडिकुलर ड्रॉ करते हैं तो वो कॉर्ड को बाइसेक्ट करेगा, ठीक है। और वो भी रिजल्ट है हमारे पास इक्वल आर्क सबटेंस इक्वल एंगल एट द सेंटर, ठीक है। अभी मैं कहना चाहता हूँ कि अगर ये ओ सेंटर अगर है, अगर मैंने परपेंडिकुलर ड्रॉ कर दिया, ठीक है बेटे, तो इसका मतलब क्या है, हमारे पास बीइंग द रेडियस ऑफ अ सर्कल दिस साइड इज इक्वल टू दिस साइड इज कॉमन, दिस इज 90 डिग्रीज, सो बाय राइट एंगल हाइपोटेन्यूज साइड कांग्रुएंस ट्रायंगल्स आर कांग्रुएंट। अगर ये वाली साइड ए थी तो ये दोनों को बाइसेक्ट कर देगा, यानी a/2 और a/2 आ जाएगा। यानी किसी सर्कल के सेंटर से अगर मैं परपेंडिकुलर ड्रॉ करता हूँ किसी भी कॉर्ड को, तो इसका मतलब वो कॉर्ड को बाइसेक्ट करता है। एक बात आपको और ध्यान देनी है कि किसी भी सर्कल के अंदर द कॉर्ड विच इज नियरर टू द सेंटर इज लॉन्गेस्ट। यानी अगर ये दो कॉर्ड्स अगर मेरे पास हैं, ये सेंटर अगर है हमारे पास, दैट ए बी एंड सी डी आर द टू कॉर्ड्स ऑफ अ सर्कल, ओके। अगर मैं ये परपेंडिकुलर ड्रॉ करता हूँ, लेट दिस बी एम, लेट दिस बी एन, इन सबके प्रूफ 9th क्लास की बुक्स में है, आप लोग बड़े आराम से देख सकते हैं। नाउ हियर OM इज लेस देन ON, ओके, देन AB इज ग्रेटर देन CD। इस सर्कल के सेंटर से अगर मैं परपेंडिकुलर ड्रॉ करता हूँ किसी कॉर्ड के ऊपर, द कॉर्ड विच इज नियरर टू द सेंटर इज ग्रेटर। ऐसे ही द कॉर्ड विच इज ग्रेटर इज नियरर टू द सेंटर, इसका कन्वर्स भी ट्रू है हमारे पास। आप प्रूफ करेंगे तो पाइथागोरस थ्योरम से बड़े आराम से इसका प्रूफ आ जाएगा। r² आप लोग कंपेयर कर लीजिएगा। आप कहते हो तो मैं कर भी दूंगा, कोई ऐसा इशू नहीं है, बट सिंपल सा रिजल्ट है, ये उम्मीद करता हूँ कि आपको आना चाहिए, ठीक है। ऐसे ही होता है हमारे पास कि अगर हम बात कर रहे हैं, मेन एक थ्योरम है हमारे पास डिग्री मेजर थ्योरम। डिग्री मेजर थ्योरम के बारे में बात करते हैं, ठीक है बेटे। मैं ये कहना चाहता हूँ कि अगर ए बी हमारे पास कोई भी अगर आर्क अगर है, ए बी वाली आर्क सर्कल के सेंटर में जितना भी एंगल बनाएगी, और यहाँ पर कहीं पर भी एक पी वाला पॉइंट अगर है हमारे पास, तो एंगल ए और बी जो होता है हमारे पास इज ट्वाइस ऑफ एंगल ए बी भी होगा, ठीक है। इसका प्रूफ मैं आपको बता देता हूँ क्योंकि बहुत जरूरी थ्योरम है, इसलिए मैं इसका प्रूफ बता रहा हूँ आपको। हमने इसको ज्वाइन कर दिया, लेट दिस पॉइंट बी ओ सेंटर। सिंस अगर सर्कल है हमारे पास तो रेडियस सभी के बराबर, रेडियस बराबर होएगी, दैट इज OP इज इक्वल टू OA इज इक्वल टू OB। तो इसका मतलब क्या है बेटा हमारे पास कि अगर किसी ट्रायंगल के अंदर आप सभी को मालूम है कि कोई भी दो साइड्स अगर बराबर हैं तो उसके अपोजिट एंगल्स बराबर होंगे। OP अगर OA के बराबर है तो ये वाला एंगल x, तो ये वाला भी एंगल x हो जाएगा हमारे पास। ऐसे ही अगर OP जो है OB के बराबर है, अगर ये वाला एंगल y हुआ तो ये वाला भी एंगल y हो जाएगा बेटे हमारे पास, ठीक है। मैंने इसको एक्सटेंड कर दिया तो आप देखेंगे लेट दिस पॉइंट भी m, कहीं पर भी है, ये वाला x पे कितना हो जाएगा हमारे पास, ट्वाइस ऑफ x बाय द एक्सटीरियर एंगल प्रॉपर्टी ऑफ अ ट्रायंगल। ये वाला y ये कितना हो जाएगा हमारे पास, ट्वाइस ऑफ y। तो इसका मतलब ए और बी वाला एंगल कितना हो जाएगा हमारे पास, ट्वाइस ऑफ x प्लस ट्वाइस ऑफ y, दैट इज 2 टाइम्स ऑफ x प्लस y। ध्यान से अगर आप लोग देखेंगे x प्लस y किसके बराबर है, दैट इज 2 टाइम्स ऑफ एंगल AB, एंगल AOB, ठीक है। चाहे AB वाली माइनर आर्क हो चाहे मेजर आर्क हो, सेम चीज आप लोग देख सकते हैं। चाहे आपको सेमी सर्कुलर आर्क होती है तब भी आपका सेम तरीके से ये रिजल्ट प्रूफ हो जाएगा। चाहे AB इज अ डायमीटर यू कैन से, तब भी हमारे पास ये रिजल्ट आ जाएगा। इफ दिस इज O, सेम लॉजिक से ये वाला x आ जाएगा, ये ट्वाइस ऑफ x आ जाएगा हमारे पास, ये इसके बराबर है, ये वाला y ये ट्वाइस ऑफ y आ जाएगा हमारे पास, ठीक है। चाहे हमारे पास एक मेजर आर्क आ जाए सबके लिए आ जाएगा, ठीक है, सेम लॉजिक से, ठीक है। ये वाला पॉइंट P है फॉर एग्जांपल, तो OP इज इक्वल टू OA, दिस इज x, सेम लॉजिक से दिस इज ट्वाइस ऑफ x, ये इसके बराबर है, दिस इज y, दिस इज ट्वाइस ऑफ y। सभी केसेस में इसी तरीके से हमारा रिजल्ट हो जाएगा। एक केस वैसे और बनता है हमारे पास, उसमें आप देख सकते हैं अगर मेरे पास ऐसा कुछ दिया हुआ है स्ट्रेट में, ओ ए बी, ये वाला पॉइंट P अगर है मेरे पास, मुझे इसमें प्रूफ करना है कि ए ओ बी वाला जो एंगल दिस बी एम, मुझे अगर इसमें प्रूफ करना है कि ए ओ बी जो है वो इसका ट्वाइस है, तो ध्यान से देख सकते हैं हम लोग कि ओ पी तो ओ ए के बराबर है, ठीक है बेटे। तो ये वाला एंगल अगर एक्स अगर है तो ये वाला एंगल एक्स हो गया, तो ये वाला एंगल किसके बराबर हो जाएगा, ट्वाइस ऑफ एक्स। यहाँ तक तो कोई शिकायत नहीं। ओपी अगर ओ ए के बराबर है, ठीक है, बिकॉज ओ इज द सेंटर ऑफ द सर्कल, ये वाला एक्स तो ये वाला ट्वाइस ऑफ एक्स हो जाएगा। ओपी ओ बी के बराबर है, दिस एंगल इज कंप्लीट बाई, ओके, दिस इज कंप्लीट बाई, दिस एंगल बिकम्स 2y, blue angle becomes 2y, that is angle BOM becomes twice of y, okay, then and angle AOM becomes twice of x by exterior angle property. You can see here as angle AOB is 2y minus twice of x, AOB becomes twice of y minus twice of x, this is 2 times of y minus of x, and you can see here as this whole angle is y, okay, this complete angle is y, so if you subtract y minus of x, it becomes twice of angle APB, again, that is angle AOB is twice of angle APB, okay, this angle AOB becomes twice of angle APB. Hope it is clear to all of you. This is the degree measure theorem. It is very important theorem in the chapter circle, okay. Next theorem is angles in the same segment are equal. Angles in a same segment are equal. We can do like this, that is, we know that if AB is any R and P and Q are any 2 points here, okay, we have proved that, we have already proved that angle AOB is twice of angle APB, ये वाला पॉइंट कहीं पर भी था बेटा हमारे पास अभी, तो AOB is also twice of angle AQB. We have proved that again the degree based theorem that if O is the center of a circle, AB is R, then angle AOB is twice of angle APB, AOB is twice of angle AQB. So from here we can get angle APB is equal to angle AQB. That is an arc subtends equal angle at the any 2 points of the circle. Okay, its converse is also true. If you want to say, and I can prove the converse as well, like this way. It has been, let's say, it has been given that APB is equal to angle AQB. And it has been given that APB वाला जो एंगल है बेटे, वो AQB के बराबर गिवन है, और AQB जो है, और मुझे प्रूव करना है कि Q वाला पॉइंट सर्कल के ऊपर लाई करता है, तो हमने कहा लेट इट पॉसिबल Q does not lie on the circle, that Q lies outside the circle. That is possible. Q lies outside the circle because this plane, this bigger circle divides this plane into 3 parts. There are infinitely many points which lie outside the circle. There are infinitely many points which lie inside the circle. There are infinitely many points which lie on the circle. We have to prove that if the arc subtends equal angle at the 2 different points, then all the 4 points are concyclic. Okay, I'm proving this result. So when let it possible Q does not lie on the circle, then 2 cases may arise, whether the point Q lies outside the circle or Q point lies inside the circle. So we are considering the first case when the point Q lies outside the circle. So what we can do is, when Q lies outside the circle, it definitely cuts the circle at some point K. It definitely cuts the circle at any point K, just write BK. Now P and K lie in the same circle, that is this angle is equal to this angle. Okay, you can say as angle 1 must be equal to angle 2. But it is given that angle 1 is equal to angle 3. It is already given that APB is equal to AQB. Okay, and we are assuming that Q point lies outside the circle, then it cuts the circle at a point K, just join KP. Now, as we have proved here that an arc subtends equal angle at the 2 different points, so angle 1 is equal to angle 2 by using angles in the same segment theorem. Okay, so it is given that angle 1 is equal to angle 3, but we have proved that angle 1 is equal to angle 2. So we can get angle 2 is equal to angle 3. Angle 2 is equal to angle 3. But here angle 2 is equal to angle 3 plus angle 4. By using exterior angle property, it says angle 2 is greater than angle 3. So both the statements are contradict each other. दोनों स्टेटमेंट जो है बेटा एक दूसरे को कॉन्ट्राडिक्ट कर रही हैं. एक कहता है कि एंगल 2 जो है वो एंगल 3 के बराबर होगा, एक कहता है कि एंगल 2 जो है वो एंगल 3 से बड़ा होगा. तो बोथ कैन नॉट बी पॉसिबल. ओके, तो इसका मतलब क्या है, Q वाला पॉइंट जो है वो सर्कल के बाहर लाई नहीं कर सकता है. सो वी आर कंसीडरिंग द सेकंड केस व्हेन द पॉइंट Q लाइज इनसाइड द सर्कल. It is being given that APB is given to be AQB. Okay, it is given that this angle 1 is given to be equal to angle 2. So what we are doing is we just produce AQ to cut the circle at a point K. We just produce AQ to cut the circle at a point K and join KB, and let this angle be 3. Now P and K lie on the same circle, and by using angles in the same segment property, what we are getting is angle 1 is equal to angle 3. It has been given that angle 1 is equal to angle 2, that is APB is equal to AQB. We have to prove that Q lies on the circle. In the first case, we have to consider that if Q lies outside the circle, it contradicts a statement. Now, if we are considering the case when the point Q lies inside the circle, and it has been given that angle 1 is equal to angle 2, what we have done is we have just produced AQ to cut the circle at a point K. So, join KB, then now P and K lies on the same circle, therefore angle 1 must be equal to angle 3. As it is given that angle 1 is equal to angle 2, it means that angle 2 is equal to angle 3. But again, in triangle KBQ, angle 2 is equal to angle 3 plus angle 4. By the exterior angle property, it means angle 2 is greater than angle 3. Again, both the statements contradict each other. So Q cannot lie inside the circle. So Q cannot lie outside the circle. Q cannot lie inside the circle. So Q must lie on the circle. That is, if the R subtends equal angle at the two different points, then all the 4 points are consecutive. Okay. Now we will do one more important result. There is angle in a cyclic quadrilateral are supplementary. That is, if ABCD is a cyclic quadrilateral, then we have to prove that angle A plus angle C is equal to 180 degrees, as well as angle B plus angle D is equal to 180 degrees. So how can we proceed? There are two different ways, at least. So in this way, as we have done earlier, that an arc subtends equal angle. So this is angle X and this is angle X. That is, this arc AB subtends equal angle at the two different points C and D. That is, this angle is X, this angle is also X. Now consider this arc BC. This arc subtends angle Y here. It should subtend angle Y here. Okay. Now in triangle ABC, what we get is X plus Y plus angle B. X plus Y plus angle B is equal to 180 degrees by angle sum property of a triangle. Now X plus Y is equal to this. This is angle D plus angle B. Comes out to be 180 degrees. Okay. And we know that in a quadrilateral, A plus B plus C plus D, angle sum is 360 degrees. D plus B is 180. So we can get here as well, that is A plus C comes out to be equal to 180 degrees. Okay. We can have one more important result here as, that is, in a cyclic quadrilateral, exterior angle of a quadrilateral is equal to interior opposite angle. That is, if ABCD is a cyclic quadrilateral, let this be X, capital X, then this angle 1 is equal to angle 2. So we can do this property as like this. Since angle 1 plus angle 3 is equal to 180 degrees, linear pair, also angle 2 plus angle 3 is equal to 180 degrees. Okay, it means angle 1 plus angle 3 is equal to angle 2 plus angle 3. So we can cancel out angle 3. So angle 1 comes out to be equal to angle 2. Okay, so exterior angle of a cyclic quadrilateral is equal to interior opposite angle. Their converses are also true. That is, in any quadrilateral, sum of opposite two angles is 180 degrees, then the quadrilateral is cyclic. And this converse is also true. If you want to say that, I can prove as well. They converses as well. Okay. Likewise, if we have been given that angle A plus angle C is equal to 180 degrees, you have to prove that ABCD is a cyclic quadrilateral. Okay. I am proving this result as well. Like if it has been given that, again, let us say, if possible, ABCD is not a cyclic quadrilateral, then what happens? Either C lies outside the circle or C lies inside the circle. if it has been given that in a quadrilateral, angle A plus angle C is given to be 180 degrees, and we have to prove that ABCD is cyclic, we assume that is possible, C cannot lie on a circle. Then there are the two possible, either C lies outside the circle or C lies inside the circle. So we are considering the first case where C lies outside the circle, that is ABCD is a quadrilateral, where it has been given that is, you can say as angle 1 plus angle 2, it has been given that angle 1 plus angle 2 is equal to 180 degrees, and we have to prove that C must lie on the circle. I am considering the first case when C lies outside the circle, then joint DC, there exists a point K, you can say as which cut the circle as the joint BK. Okay, ABCD is a cyclic quadrilateral, ABCD is a quadrilateral in which it has been given that angle 1 plus angle 2 is equal to 180 degrees. So if possible, let C lies outside the circle with a joint DC which must cut the circle at a point K, just joint BK, and this angle becomes 3. Now since ABKD is a cyclic quadrilateral, so we can have angle 1 plus angle 3 is equal to 180 degrees. Okay, but it is given that angle 1 plus angle 2 is equal to 180. So what we have is angle 1 plus angle 3 is equal to angle 1 plus angle 2, cancelling angle 1, it comes out to be equal to angle 3 is equal to angle 2. Okay, but we can see that in triangle BCD, angle 3 is equal to angle 2 plus angle 4. That is again angle 3 is greater than angle 2. Again both the statements contradict each other. It means C cannot lie outside the circle. Okay, now we are considering the case in which C lies inside the circle. That ABCD is a quadrilateral, you can say like this, that ABCD is a quadrilateral in which it has been given that angle 1, this is angle 1, you can say this is angle 3, angle 2, angle 1 plus angle 2 is given to be equal to 180 degrees. We have to prove that C lies on the circle, so let us assume that C lies inside the circle. If C lies inside the circle, produce DC, it must cut the circle at a point K, here, just join BK, let this angle be 3. Okay, now ABKD is cyclic quadrilateral, so it means angle 1 plus angle 3 is equal to 180 degrees. But it has been given that angle 1 plus angle 2 is equal to 180. So what we have is angle 1 plus angle 2 is equal to angle 1 plus angle 3. Is cancelling angle 1. We can have angle 2 is equal to angle 3. Okay, let this angle be angle 4. So we have angle 2 is equal to angle 3 plus angle 4. It means angle 2 is greater than angle 3. Again, there is a contradiction. It says angle 2 is equal to angle 3. It says angle 2 is greater than angle 3. It is a contradiction, that is C cannot lie inside the circle. So C cannot lie outside the circle, C cannot lie inside the circle, it means C must lie on the circle. Easy. Now we can have the contradiction part of this case as well. That is, if angle 1 is given to be angle 2, then you have to prove that all the 4 points are consecutive. Okay, we will prove this result as well. So how can we prove here that if it has been given that in a quadrilateral, exterior angle of a quadrilateral is equal to interior opposite angle, okay? So that is possible, you can say as this is, that is possible at D lies outside the circle. Again, it is being given that angle 1 is given to be equal to angle 2. That is possible, it is being given that angle 1 is equal to angle 2. We have to prove that ABCD is cyclic. So let it possible D lies outside the circle, that it cuts, then CD cuts the circle at a point K. Just join AK. So let this angle is 3. Again same argument. Since ABCK is a cyclic quadrilateral, so angle 1 is equal to angle 3. But it is being given that angle 1 is equal to angle 2. So it implies that angle 2 is equal to angle 3. Easy. But here again, angle 3 is equal to angle 2 plus angle 4. That is, angle 3 is greater than angle 2. That is, again it is a contradiction, so it means D cannot lie outside the circle. Same case, we can prove that if D lies inside the circle. That is, if ABCD is a quadrilateral, in which it has been given that the exterior angle, angle 1, is equal to angle 2, and we have to prove that D lies on the circle. So let us produce CD to cut the circle at a point K. Produce CD to cut the circle at a point K, and just join AK and let this angle be 3. Since ABCK is a cyclic quadrilateral, again angle 1 is equal to angle 3, but it has been given that angle 1 is equal to angle 2. it implies that angle 2 is equal to angle 3. Okay, but here what we have is angle 2 is equal to angle 3 plus angle 4. That is angle 2 is greater than angle 3. Again contradiction. That is D cannot lie inside the circle. So D cannot lie outside the circle, D cannot lie inside the circle. It means D must lie on the circle. Okay. Now I am telling you one of the important results, that is called Ptolmey's theorem. Ptolmey's theorem states that in a cyclic quadrilateral, it is one of the beautiful results in geometry, and we will use this result in a beautiful way in further problems. Okay. So if ABCD is any quadrilateral, I am just telling you here. That is, if ABCD is any quadrilateral basically, okay, and let the sides be small a, small b, small c, small d. If ABCD is any cyclic quadrilateral with diagonals x and y, then the Ptolemy theorem states that AC plus BD, that is this side into this side plus this side into this side, is equal to x into y. That is the product of the diagonals. That is in a cyclic quadrilateral, this side into this side plus this side into this side is equal to x into y. That is the product of the diagonals. So how we can prove this result? We need AB, BC, CD, DA and AC and BD. Okay. So what we are doing is, we just produce CD to some point T such that we are constructed such that this angle is equal to this angle. Okay, we have constructed an angle such that angle 1 is equal to angle 2. That is, we have done a construction. Draw angle DAT, which is equal to angle BAC, such that AT cuts CD produced at T. Okay, so let us see what we can do, what we are doing here. I am doing the proof in a simpler way. In triangle, you can see here as well, that is this angle is equal to this angle. This angle is equal to this angle. Exterior angle of a quadrilateral is equal to interior opposite angle. So I am considering the triangle DAT. Triangle DAT and triangle BAC. Okay. I just given the numbering 1, 2, 3 and 1, 2, 3 here. You can see here as angle ADT is equal to angle ABC. ADT is equal to angle ABC. Exterior angle of a cyclic quadrilateral, we have proved earlier. Okay. Also, angle DAT is equal to angle BAC. This angle is equal to this angle. We have constructed. This is because of construction. Okay. So both the angles are equal. Therefore, by AA similarity, what we have is triangle DAT is similar to triangle BAC. Okay. बेटा हमारे को जो प्रूफ करना है उसमें AB, BC, CD, DA, AC और BD चाहिए. AT तो हमारे को नहीं चाहिए. ठीक है. So we cannot use AT because we don't require AT. Okay. So we can have AD upon AB. This is TD upon BC. So we can have TD from here, that is AD upon AB into BC. We can have this length TD, that is AD upon AB into BC. Now see what we are considering here now. Now see that this angle is equal to this angle. Okay, angles in the same segment. This angle is equal to this angle, and let this be angle 3. Since angle 1 is equal to angle 2, and if we add angle 3 to both sides, then this complete angle, okay, will be equal to this complete angle. as angle 1 is equal to angle 2. If we add angle 3 to both sides, then this plus this is equal to this plus this. Okay, so I am considering the triangles here as in triangle CAT, in triangle CAT and triangle BAD. Hope you are getting what I am saying is, in these two triangles, angle ACT by numbering 2, 1, 3 is equal to angle ABD. Angle ACT is equal to angle ABD. Angles in a same segment. We have proved this result. Angles in a same segment. Okay. Also, we can have angle ACT, that is CAT. Angle CAT is equal to angle BAD, because angle 1 is equal to angle 2. So angle 1 plus angle 3 is equal to angle 2 plus angle 3 beta. Okay. Again by AA similarity. What we have is triangle CAT is similar to triangle BAD. Okay, again we don't require AT here, so we can write AC upon AB is equal to TC upon BD. So we can have TC here, TC is equal to AC upon AB into BD. But it is about to finish, we are about to get the desired result. So TD we have, TC we have. So what we can do right now is we can write PC is equal to TD plus DC. Okay, we can write TC is equal to TD plus DC. We have TC here, that is AC upon AB into BD, and TD is AD upon AB into BC plus DC. Okay, just multiply both sides by AB. We can get the desired result, that is AC into BD is equal to AD into BC plus AB into DC. Hope it is clear to all of you. That is, if the sides are, you can say this is A, this is B, this is C, this is D. Okay, and the diagonals are X and Y. So AD is small d, BC is C, this is BD, P into D, this is AB into DC, this into this, that is AC, this is X into Y. Hope it is clear to all of you. A very important result for Ptolmey's theorem. Okay. Now we will discuss about Brahamagupta's theorem. It states that though Brahamagupta has given a lot of theorems, this is one of the favorite theorem. It states that in any triangle ABC, if AD is perpendicular, AD is altitude drawn on BC, then we have a standard result, that is AB into AC, that is product of any two sides of a triangle, AB into AC, is equal to twice of R into perpendicular drawn to the third side. That is, in any triangle ABC, AB into AC is equal to twice of R diameter of a circle into perpendicular drawn to the third side of a triangle ABC. So you can see here as ABC is any triangle. Okay. You can see here. So if O is a circumcenter. Okay, so if I join AO and produce it to cut it up at a point E, just join AE, EC. See, this is the diameter, then this angle becomes 90 degrees. This is the diameter, then this becomes 90 degrees. And if you consider the side AC, you can observe that this angle is equal to this angle, because angles in a same segment are equal. So I am considering the triangle in triangle BDA, and triangle ECA. Okay, so what we have is angle DBA is equal to angle CEA. Angles in the same segment, DB, you can name them as 1, 2, 3 and 1, 2, 3, okay? There is 2, 1, 3 is equal to 2, 1, 3. Okay, DBA is equal to CEA. Second is 90 degrees, that is BDA, 1, 2, 3 is equal to ECA, that is 90 degrees. This is angles in same segment, okay? So, we can have by AA similarity, what we can have is triangle BDA is similar to triangle ECA. Okay, triangle BDA is similar to triangle ECA, so it becomes BD upon EC. Okay, you can write this as AD upon AC is equal to AB upon AE. So we can have AB into AC is equal to AE into AD. Okay, so AB into AC, AE is the diameter, that is twice of R into AD. So AB into AC becomes twice of R into AD. Okay. If you know, I had proved that earlier that R is equal to ABC upon 4 delta. अगर आपको याद हो तो मैंने derive किया था कि R is equal to ABC upon 4 delta. ध्यान से अगर देखा जाए, this is small b, this is small c, this is small a. Okay. So we can write here as BC as 4R delta upon A. And we can write this as twice of R 2 delta upon A. Oh, please see carefully. This is 2 by A. Delta stands for area of a triangle ABC, which is half of BC, that is A into AD. Okay, you can cancel out this 2 and this A here. Again, you get the same result from here, that is twice of R into AD, and B into C becomes AB into AC. Okay, that is we again get the same result, that is AB into AC is equal to twice of R into AD. We can have many good results based on Ptolmey's theorem and the Brahamagupta's theorem. Okay, now I will teach you some topic based on tangent of circles. It is a very important topic. You should know the tangent must be perpendicular to the radius. Okay. For this you can see as, if you can prove that from a point P, if I draw the perpendicular D, then PD will be the shortest distance. Okay, आपने पढ़ा भी होगा because right angle है हमारे पास, ठीक है, x वाला point कहीं पर भी अगर है, then hypotenuse is the longest side. That is, if you have to prove that PD is perpendicular to any line L, you have to prove that PD will be the shortest distance. So tangent is a line which touches a circle at a single point, let it be P. If you have to prove that tangent is perpendicular to the radius, you just take any point Q on the tangent xy. If you join OQ, since O lies inside the circle, Q lies outside the circle, then there must be a point K which lies on the circle, because tangent is a straight line which touches the curve only at a single point. So we rest on all the points lie outside the circle.